The title of today's lecture is Drum Level Methods of Compensation Third. In this lecture, we are going to discuss some practical considerations about drum level methods of compensation. Practical considerations. This lecture is third in the series Drum Level Methods of Compensation. We are going to discuss some of the very important practical aspects without which compensation methods are not going to work. It is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. Practical considerations about sensing piping. In this diagram, we are showing typical drum level differential pressure transmitter connections. On the right, we are having the correct installation. On the left, we are having the wrong installation. Sensing piping is very important. The sensing lines to the transmitter must never run horizontally. Running these lines horizontally would allow air to collect in various spots and may change the effective height of the column of water bearing on the transmitter. The pressure at the transmitter is directly related to the height of the column of water, so large errors can be introduced by air in the sensing lines. Install the sensing lines as close to vertical as possible, with the transmitter always below the vessel. A minimum slope of 1 inch per foot of run is acceptable, but the closer to vertical, the better. Shut-off valves should be provided at the vessel. They are also called root valves, and at the DP meter. Blow down capability should be provided, and the DP meter should be located with easy access to the blowdown, usually located in the back of the transmitter. Practical considerations about basic reservoir column installation. In this diagram, we have shown drum level reservoir column basic installation. A detailed schematic representation of the basic reservoir column installation can be seen in the attached figure. In this installation, the portion of the reference leg between the measurement taps is assumed to be at 100 degrees Fahrenheit, which is a reasonable assumption for a boiler whose drum is located indoors. In the attached figure, A level reservoir is shown on the reference leg. This is not a must, but it does give a good transition from hot steam in the horizontal portion of the leg to ambient water in the vertical portion of the leg. It is recommended by many practitioners that the level reservoir must be installed. The horizontal leg contains saturated steam that is continuously condensing and running back into the drum. Thus, it is always near drum temperature and should be protected from contact but not insulated. Outdoor installations may require freeze protection on sensing lines. It should be noted that if the reference leg temperature varies widely from the 100 Fahrenheit assumption, the resulting measurement error may be significant. Consideration could also be given to measuring this temperature and including it in the compensation equation. Our discussion about drum level methods of compensation cannot be complete without discussing about temperature equalizing column used for steam drum level measurement earlier. This is the diagram for temperature equalizing column. In the 1950s, temperature equalizing columns were commonly used in steam drum differential pressure based devices for measuring water level. These temperature equalizing columns can be problematic because during boiler operation they keep the reference leg at a high temperature. As a result, a portion of the reference leg can flash to steam on a rapid pressure decrease, that is load increase, and this reaction will result temporarily in a false high level measurement, which adds to the boiler swell effect. Measurement inaccuracy can also be related to the use of these columns because the temperature of the reference leg requires an assumed temperature. It is time to replace these antiquated instruments with a more modern reference leg. It is hoped that this lecture is useful to you. Please press like. Please subscribe.